Okay, what's up, everybody? Hope that you had a good day yesterday and got everything done with us in our time together. So hopefully this video will be short and you'll have another easy day here, and then we'll meet again tomorrow on the Zoom session at 9:30. So the notes from today's video need to be done by Friday, tomorrow at 9:30 when we meet. Okay, so actually today is nothing new. It's just a different shape. So we're going to find the surface area of a different shape. We're going to find the surface area of a cylinder. So let's share my screen with you here and get started in doing this. All right, so we are on page 693, so if you want to follow along. So it's kind of the same idea as last time. We're going to find the lateral surface area of a cylinder, which, if you don't know, a cylinder, looks like this. Okay, like a can, basically. All right, and that's a horrible one, so we'll just get rid of it so you don't judge me on that. But we need to find the lateral surface area. So if I have a cylinder that looks like can, so what we're trying to find in the lateral surface area is like the area of the stuff on the outside, the stuff around here, not the top and the bottom, not the bases, like yesterday, not the bases, but the area of the stuff around the outside. Well, if you think of a cylinder, there's two ways kind of to think about this. If I were to cut it like down the middle, if I took scissors and just kind of cut it and then unfolded it, it would unfold itself into a rectangle. Think of that. Take a piece of paper and do something like this. I'll show you. Take a piece of paper, which is like a triangle, and just make it into a cylinder. How would I find the area of this rectangle? Okay, well, I'm going to do the same thing I've been doing. So I'm going to find the lateral surface area by finding the perimeter of the base and multiplying it by the height, which in essence is doing base times height. Okay, so I'm going to turn the screen back onto the iPad here. All right, so if you're confused about that, you won't be in a second. Here we go once it starts right there. Okay, so let's say I have this cylinder and I need to find the lateral surface area of this cylinder. Well, I need to know the perimeter so I can multiply it by the height. Let's say the height is 8. All right, let's just make up some numbers. And let's say that the radius is 2. All right, so a cylinder with a radius of 2 and a height 8, find the lateral surface area of that figure. And you think, like, okay, I got to find the perimeter. Wait, there's no perimeter. Well, there is a perimeter. We just don't talk about it that way. We don't use that term. We use a different term when we're talking about the perimeter of a circle. What do we use? What's that term? For some of you thinking about it, how do I find the distance around this circle? What is that called? It's called the circumference. And we all know that to be able to find the circumference, that's just taking 2 times the radius and multiplying it by pi. Or the other way we've written it is just saying, okay, it's the diameter times pi. So that's how I'm going to find the circumference, which is, in a circle, the perimeter. So if I'm talking about trying to find the lateral surface area and I need to know the perimeter so that I can multiply it by the height, then that's pretty simple. I'm going to find in a cylinder the circumference, which is the perimeter, and multiply it by the height. So my lateral surface area in this figure would be the perimeter, which is the same as the circumference. So 2 times the radius pi times the height, which is 8. So let's multiply all that out. And I get, we don't need that r in there, obviously. So I get 16 pi. Now, if I wanted an approximation where it said round to the nearest tenth, I could take that and I could say, okay, let's take that and multiply 16 times pi. Let's get the calculator up. 16 times pi equals 50.2. Well, we rounded to the nearest tenth, 50.3. So the lateral area, if I was rounding to the nearest tenth, would be 52, oh, sorry, 50.3. Okay, so that's lateral surface area of a cylinder. Okay, like I said, nothing new. The only new thing here today is that we have to remember that if I'm talking about perimeters of a cylinder, the perimeter is the circumference of the base. And the circumference I find by using one of those two things, either that the circumference is 2 pi r, or 2 times the radius times pi, or the diameter times pi. All right, let's move on. Let's look at surface area. So if I'm going to find the total surface area of a cylinder, and I already know how to find the lateral area of the cylinder, the area of the part around the can, all right, then I just need to figure out how do I find the area of the actual circle on the base and the other base, the two bases. Well, that's going to be the same as yesterday. I'm going to find the area of each base and add it to my lateral surface area. So let's say I have a cylinder that has a radius of 8.3 and a height. And again, this isn't drawn to scale, so don't judge me on that. So let's say I have a cylinder that has a radius of 8.3 feet and a height of 6.6. Find the total surface area of this figure. Okay, so let's first find the lateral surface area and then add that to the area of bases. And that will give me the total surface area. Again, no different than yesterday. This right here is no different than what we did yesterday. Same thing. The only difference is how am I finding the lateral surface area of a cylinder? And I have to find the perimeter in order to do that. And the perimeter of a cylinder or of a circle is the circumference. So let's find the circumference of the base, which is going to be 2 pi r. So 2 times 8.3 pi. That will give me the circumference times the height of the cylinder, 6.6. That's going to give me the lateral area of the cylinder. Now let's take, since I have two bases, let's take the area of one base and multiply it by 2. What do I do to find the area of a circle? I take the radius and square it. So it's 8.3 squared times pi. The area of a circle is pi r squared. Remember that? Of course you do. So 8.3 squared times pi. And since I have two bases, one on the bottom and one on the top, I'm going to multiply it by 2. Okay, so now let's just do the math. Let's do 8.3 times 2, which should be pretty simple. 8.3 times 2, 16.6 pi. I'm just going to leave it like that for now. Multiply it by 6.6, add that to what's 8.3 squared, and then multiply that by 2. I get 137.78, 137.78 pi. Okay, and 16.6 times 6.6, 16.6 times 6.6 is 109.56 pi plus 137.78 pi. So let's do 109.56 plus 137.78. 137.78. 247.34. 247.34 pi, right? So I've simplified that. So this is the total surface area. Now, does it say it around? But we can. We'll just do that, 247, take our answer to that and multiply that by pi. And I get 777.0. So that is 777 square feet. And that is the answer, approximately. So if I want an exact answer, I'd leave it like that. If I want an approximation, I'll go ahead and multiply it out and use pi, multiply it out, okay? So that's the how to find the surface area of the base. There's one other, or sorry, the surface area of a cylinder. So there's one other example I want to show you before we get started, or before we get ready to do homework tomorrow, and that is something like number 4 on page 695. So here we have number 4. It says the surface area of a cylinder is 96 pi. So I have a cylinder that has a surface area of 96 pi, okay? And it has a height of 8 centimeters. And it says find the radius. So I'm going to find the radius. That's 8. Okay, we're going to find the radius if the height is 8 and the total surface area is 96. So let's just write out how, what do I know? Okay, surface area should be the lateral area plus the area of the 2 bases. Okay, so that's kind of how I'll just abbreviate this. This is the total surface area should be equal to the lateral surface area added to the area of the 2 bases. Okay, so that's, now we'll just plug in what I know. What is the total surface area? It told me it's 96 pi. And the lateral surface area, how do I find that? Well, I take the circumference and multiply it by the height of the cylinder. So what is the circumference? The circumference is 2r times pi, right? Times, to find the lateral area, I need to times that by the height, 8. Add that to 2 times the area of each base. So the area of each base, how do I find the area of a base? Pi r squared. Okay, we don't know what r is, so we're just going to write it like that. So now I just have to solve for r. Okay, I have all of my information in now, just solve for r. So let's multiply it out first. And I get, this is 16 pi r plus 2r squared pi. And then let's put all of the terms on the same side. So I get 2r squared pi, and I'm just rearranging it here just to make it easier to see, minus 96 pi. All right, now let's factor this so that I can solve for r. Let's factor out a 2 pi. That's a common factor in all 3 of these terms is 2 pi. So let's factor out a 2 pi. If I take a 2 pi out of this first thing, I will get r squared plus 8r minus, what's half of 96? 48. Okay, so there is my new equation with a 2 pi factored out. So now I just need to solve for r by factoring these things. And this is where you're going to have to use your algebra. You could use the quadratic equation, but I think we could do it easier. I need something that's going to multiply to 48 and add to 8, or subtract to 8. So those things aren't doing it yet. It's probably going to be that. Yes, 12 minus 4 is 8. So I need to subtract to positive 8. So 12 minus 4 is 8, and 12 times negative 4 is 48. It's like reverse FOIL from algebra. Okay, so now let's solve for r. So r plus 12 equals 0, or r minus 4 equals 0. So r is equal to minus 12, or r is equal to 4. Well, I can't have a negative radius. That doesn't make sense. So r must be 4. All right. So when given the surface area, I can also find the radius of the circle or the cylinder, and I could also find the height if they wanted. If they gave me the surface area and the radius, I could find the height doing the same thing. So that's all for today. We will work on some of these problems on Friday tomorrow. See you then. All right, have a good day.